We'll have to look at it in review, but we don't have to use it. It's not ever really going to be the way that you solve a problem anymore, because there's better ways. Not that I'm aware of, anyway. If you get much beyond what I know, maybe, but it's that understanding of how that turns into a derivative is what they're wanting to test. So, good news is L'Hopital's rule will even work on those for a lot of them. So sometimes you can do it without actually. All right. So this question that we have here, this is going to cover a few different things. So I've got a couple here that basically we're going to be looking at this, and it's going to have initial conditions. Okay? So everything we've been doing so far were just general solutions. All of our answers still had C's in them last night. What's going to happen for these problems is going to be that we are given an initial condition here for these problems. So, we've got this differential equation. They give us the initial condition, meaning that on the solution of this problem, y of 3 equals 1. Okay? So, everything's going to start just like it did yesterday. We need to separate. We need to integrate both sides. If we may want to solve for y, or we might want to find c. We'll talk about that in a minute. Depends on the problem, what's easiest. So first thing we need to do here is we need to take this differential equation and we need to separate the variables. How are we going to do that for this problem? The problem with if I do that is that I will get dy dx minus y squared. And I need that dy to be multiplied by my y. You don't want your dy to be in the bottom. So pretty much, like, you always want to do times dx over here. Or you can always do that as a first step if you want. And then we got to figure out a way to get those y's over to the other side. And adding and subtracting is not going to work. Excellent. Because xy squared is really just x squared y squared, right? So I can pull a y squared out of that expression. It will leave me with 1 minus x squared. Yes. And then, once you do that, now how can I get rid of the y squared? Divide it. So, you can do 1 over y squared if you want. I would do y to the negative 2 power. And be careful with this. Please do not lose your dy and your dx. Those are important for the problem. If you are lazy and leave them off, it could cause you to miss the problem. Particularly on calculator, not calculator, on FRQs. Multiple choice, maybe you could get away with it because they're not checking your work, but FRQs, it's going to be important. Okay, are we okay here? All right, everything is separated. That's half the battle. Now we need to integrate both sides. So this is going to be y to the negative 1. We would divide out front by that negative 1, so we just get negative there. Equals, this is going to be x minus, we'll get x to the third. I have a 1/3 here, and then we want to put a plus c on the end. All right, so you can see that all of your answer choices are solved for y. So we know we are going to have to solve this for y. There, you have some options here on what you want to do. You can solve for c now, or you can solve for c once your equation is solved for y. It really doesn't matter. Sometimes it may be easier one way or the other. A lot of times it doesn't matter which one you choose. I would suggest solving for c first from a FRQ perspective, because what will usually happen on these, as far as scoring goes, is like if it's a 5-point problem, you get a point for separating your variables. You get usually a point apiece for integrating both sides, or you get a point for integrating and then a point for writing the plus c. Like if you just have the plus c, it is a point alone. Then you get a point for plugging in initial conditions, and you get a point for solving for y. If you don't solve for y correctly, it can mess up that initial condition part. So sometimes it can be better to solve for it now, although really it could go either way. So what I would do is I would make this negative 1 over y instead of negative exponents. So I got x minus 1/3, x to the third plus c. And they have told us that y of 3 equals 1. So y of 3 equals 1. That's a point on this solution curve. So that is the point, 3, 1. So we're just going to plug in 3 and 1. So I will have negative 1 over 1 equals 3 minus 1/3 times 3 to the third power plus c. So negative 1 equals 3 minus 9 plus c. Negative 1 equals negative 6 plus c. We will add our 6. And so c is going to equal 5. So that means that our equation is negative 1 over y equals x minus 1/3 x to the third power plus 5. I think, if I've done everything right. Any of these answers. I hope. I think I see which one's going to be the answer, but it's not clearly obvious right away. We okay there? Does that make sense? So what we're adding to what we did yesterday is we are plugging in the points and finding the actual value for c. You do not, because this is not the derivative. You're plugging it into the solution, which only has just x's and y's. So you are just taking those values and plugging them into this. I don't think so. If you want to, you can. But they will assume that you know that that's the point. So if you just go straight to plugging it in right here, you would be fine. Other questions? 3 cubes is 27.
Oh, it is 27.
Yeah, careful. Yeah. Yeah. All right, we good here? All right, now, as you can see, we don't have any of these answer choices, and we don't even have anything that like clearly matches one of those answer choices where we could figure it out without working the rest of this out. So, if we want to solve for y, we're going to have to multiply both sides by y, because we cannot solve for y when it is in the denominator. And then once we multiply by y, we need to divide both sides by this bunch of stuff that's in that set of parentheses. So that is going to give us negative 1 over x minus 1/3 x to the third plus 5 equals y. So, that's not an answer choice. Probably, it's going to be one of our answer choices, but we got to get it to match, right? It's looking like, it looks more like B than anything, right? Although it's not too far off from A. C and D look pretty different. Like I would, especially D, like at this point, I don't know where an E would come from, so I do know exactly where students would get an E from. They would do natural log of y squared over here, because you get in the habit of like anything in the denominator being a natural log. That is not the case if it's to a different power than 1. But all I've got to do here, see I have this -3 on top. If I multiply the top by 3 and the bottom by 3, which is perfectly legal move, because that is just like multiplying by 1. I've got -3 over, distribute this out, 3x minus x to the third plus 15. That is answer choice B. And probably they chose to do that so that they would not have a complex fraction where they got that fraction inside the fraction, because multiplying by 3 gets rid of that 1/3 right there. It is something I would not suggest doing on an FRQ. On an FRQ, I'd leave the complex fraction because they're not going to count off for that. It's still going to be correct. So if it were FRQ, I would have stopped here without doing that, but you've got to get it to match an answer choice. So. Okay, questions? Okay. Example 2 is probably an actual FRQ I got from somewhere, but I didn't mark it, so I can't tell you where it came from necessarily. But this is what an FRQ for a differential equation often looks like. So if we have dy dx equals y minus 1 over x, the first thing they ask us to do here is to do the slope field. So this is going to kind of review everything we've done pretty much in Unit 7. So, we've got, if you want to make a table, you can, but you don't necessarily have to. So we've got the points 1, 0, 2, 0, 3, 0. Then we got 1, 1, 2, 1, 3, 1, and 1, 2, 2, 2, and 3, 2. So if we're plugging in to y minus 1 over x, 0 minus 1 over 1 is going to give us -1. So we have a slope of -1 here. 0 minus 1 over 2 is going to give me -1/2. And 0 minus 1 over 3 is going to give me -1/3. What will I get for all of these coordinates where I've got a y equal to 1? I'm going to get 0 because my numerator will be 1 minus 1, which will give me 0. Doesn't matter what you divide it by as long as it's not 0. So I'll get 0 for this whole row right here. So that'll just be a line of 0 slopes. And then 2 minus 1 over 1 is going to give me 1. 2 minus 1 over 2 is going to give me 1/2. And 2 minus 1 over 3 is going to be 1/3. So they would ask you to sketch that part of the slope field. Any questions on it? Okay. B is going to say, let y equal f of x be the particular solution to the differential equation with the initial condition f of 3 equals 2. Write an equation for the line tangent to the graph of y equals f of x at x equals 3. Use the equation to approximate the value of f of 3.3. So this is a tangent line problem. It is not a solve the differential equation problem. What I often find, especially like past this unit, is students read this and they start solving the differential equation. C is going to ask you to solve the differential equation. That is where you're going to solve. Right here, this is a tangent line problem. Tangent line problems need a point, which they have given to you. It's 3, 2. A slope, and what do we use to find our slope? dy dx. So we'll say dy dx such that xy equals 3, 2 is going to be, it's just y minus, what is it, 1 minus y? Y minus 1 over x. So y minus 1 over x is going to be 2 minus 1 over 3, which is going to give us 1/3. So there's our slope. Our tangent line is going to be y equals 1/3 times x minus 3 plus 2. And then we are to use this tangent line to approximate f of 3.3. So f of 3.3 would be approximately 1/3 times 3.3 minus 3 plus 2. You can leave it here on the FRQ if you would like, because you don't have to simplify. But if you do simplify, you got 1/3 times 0.3, which I am going to write as 3/10 plus 2. So that will give you 1/10 plus 2, so you will get 2.1 for that. Again, it would be a pretty good idea really to just leave it right here on the actual exam. I want you to be able to get 2.1. You probably will have some college professors that don't like it if you try to do this stuff right here. But on the AP exam itself, it's fine to leave it there. Okay, questions on that? So none of that is solving differential equations, just a slope field and using a tangent line for that. So you want to read carefully whenever you're doing that. C is where we're going to be asked to solve the differential equation. So for this, we got dy over dx equals, what was it again? Y minus 1 over x. So we would need to multiply both sides by dx, which is going to give me dy equals y minus 1 over x times dx. We got to get rid of the y stuff. We're going to have to take the minus 1 with it because we can really only multiply and divide. We can't add or subtract stuff here. So we're going to divide by that y minus 1 here. So we're going to end up with 1 over y minus 1 dy equals 1 over x dx. Is everybody okay here? All right, so once we have separated, we now need to integrate both sides. And both sides are going to be natural logs here. This left-hand side would be like a tiny u/du substitution, but the u would be y minus 1. What's the derivative of y minus 1? Just 1 dy. So you're not really going to have much of a u/du substitution there. This is just going to give you natural log of the absolute value of y minus 1 equals the natural log of the absolute value of x plus c. You cannot just drop the natural logs because of this plus c over here on the outside. If it wasn't for that, it would be fine. So what you're going to do to both sides is going to sort of drop the natural logs. And let me point this out right here. This piece right here, y equals f of x, means that we must solve for y. So you're going to see it worded this way pretty often. This means that our answer has to be solved for y. These types of problems, so I told you guys that you can plug in and find the c before you solve for y or after you solve for y. It does not matter which one of those that you do. I don't love dealing with natural logs. So I think I would rather solve for y first on this one to get rid of those natural logs. I think it would make it a little bit easier to deal with. So that is what I'm going to do. You could solve for the c first, though, if you prefer. So if you do e to the power on both sides, this natural log will cancel. Over here, the natural log sort of cancels. Remember what we're thinking about. This is e to the natural log of the absolute value of x times e to the c, which that c can become the capital C. So we're going to have y minus 1 equals c times, I need those absolute value bars. For this scenario, I don't think it's going to matter because your x is positive. So I think you could drop it. I may have to go look at my solutions on that one, though. Those I dropped because this c right here can be positive or negative, which sort of takes care of those absolute value bars on that side. So whenever you're taking that big C and putting it out front, that will take care of your absolute value bars on the left-hand side. Let me see if I've got let me see what I did before. If I kept those or not. I think they are unnecessary. I dropped them on both sides when I solved this last. I think because we are dealing with positive numbers, we can drop them on both sides. I'm going to keep them just a little bit longer. Here. Yes. I think. Well, I think you'd still be okay because your 3 right here would be positive. I think when you would run into issues here would be like if it was f of negative 3. Yeah, if you had a negative that you were plugging in, I think you would need to keep them. So I think it will not hurt you to keep them for this problem either way. So if I take now my point is 3, 2, and I'm going to plug it in. So I've got 2 minus 1 equals c times the absolute value of 3. So I've got 1 equals c times 3. I'm just going to divide both sides by 3. I don't know why it's doing all this weird stuff here. So 1/3 is c. And so my solution would be, we'd have y minus 1 equals 1/3 times the absolute value of x. We would add that 1 over here to the other side. So y would equal 1/3 absolute value of x plus 1. Or, because of the part of the graph you're looking at here, I think it would be okay to do 1/3 just the x plus 1 because you're dealing with those positive numbers that you're plugging in. Yes. 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 So the steps that you will do each time, and I'll just to give you like an idea what points would probably be worth here also, because I think that's helpful. You would get 1 point for separating. You would get, it depends on the problem, 1 to 2 points for integrating correctly. So depending on the problem, this one I think would probably just be 1 point because they're pretty simple integrals on both sides. Sometimes if you have like a U-to-U substitution with one of them, they'll give you 2 points, like a point for integrating each side correctly, so that if you miss one side, you can still get one of those points. A lot of times, there is a point just for the plus C, just for putting it there. So, and it will also have a condition that if you don't put the plus C, you cannot get any more points on this problem. Which makes sense because you can't plug in your initial condition and find that. And then usually there is 1 point for plugging in the 0.32, and there's a point for solving for y. These first two steps have to be done first, and if you do not separate, you will get 0 points on this problem. If you do not put the plus C, you will not get any points past that point. The plugging in and the solving for y can be done in either order. So what I always tell students, whether you solve for y or not, like if you're stuck and you have no clue what to do, plug 3-2 in. A lot of times you don't even have to solve to get the C right. You just have to plug 3-2 in. So like if it's something that you don't know how to solve, it's still okay. Just plug it in and leave it and stop. You'll get all but 1 point for that problem if you've done everything else right, which is a lot of points because like that I have seen actual released FRQs where this section is worth 6 points. So very heavily weighted, and a lot of places to get points just for little things like the plus C, like plugging in the 3-2. So I actually like these FRQs. It's harder for them to throw you a curveball on them, although I have seen a couple with some curveballs. So hopefully we'll get one. I like these. Okay, questions? Okay, 3 is a different type of problem because they give you the solution. The general solution to the differential equation dy dx equals x over y is y equals plus or minus the square root of x squared plus c. Let y equal f of x be the particular solution to the differential equation with the initial condition f of -2 equals negative square root of 2. Which of the following expression for f of x and give the domain for which the solution is valid. So, do we really even need to solve for C here? Look at your answer choices. Are any of them different? They are not. So we could plug in and solve for C. We definitely don't need to solve the differential equation because they are telling you if you solve this differential equation, here is what you get. Then we could plug in and solve for C, and if we saw different numbers for our C in our answer choices, we would want to do that. But all of them have the same number. So it would be a waste of time to do that because they're all the same number. So this is really about picking out the correct answer. So let's think about the point that we're looking at. We've got negative 2, negative square root of 2 is going to be our point. So we're thinking about our equation, y equals plus or minus square root of x squared plus c. So through this particular point, okay, for this particular point, what we got to decide first is, are we going to pick a positive or a negative here? Which one should we pick? I need to pick a negative. How do we know, Connor? There's a negative in front of that square root, and the only way I can ever get a negative in front of that square root is if it was already there, right? Because nothing inside of the square root is going to be pulled out as a negative. So, unless we're dealing with some imaginary stuff, which is not what you're dealing with here. So, that rules out B and D. Okay, then, gosh, I think I need to look at my, let's see. Let me look at last year. Okay, just need to be extra sure. All right, so then I need to think about domain for which this solution is valid. Okay, so what is underneath the square root, which is our x squared minus 2, must be greater than or equal to 0. And so for that, if I move the 2 over, I got x squared is greater than or equal to 2. And then what I would do after that is I would square root both sides. And with the equal sign, if I was doing x squared equals 2, and I square rooted both sides, with the equal sign, I would do x equals plus or minus square root of 2. But I can't do that with an inequality because it doesn't make sense. Like greater than or equal to 2 different numbers just doesn't really make sense, right? So the way that we deal with that with inequalities is we're going to do absolute value of x is greater than or equal to the square root of 2. Okay. We also, if I wanted, I also could do that over here when I'm square rooting both sides, even if it's an equal sign. I could write it that way. I could do absolute value of x equals square root of 2. Because absolute value means the positive or negative would work, so that would be x equals positive square root of 2 and x equals negative square root of 2. So instead of doing a plus or minus, you can do absolute value bars. And when it's an inequality, you need to do that. And that is going to give us C here. Correct. You can't have a negative under the square root. Yes. Let me do that one. I think I need you guys to try that one. It'll separate. Are you having trouble separating it? Or it just looked hard? I'm going to let you guys do it. All right. Okay, we're going to do one more FRQ for this. And this was an actual FRQ. And I think, if I'm remembering correctly, or at least I've seen one like this before. This one is a little bit confusing because it's not differentiable, or not separable. You can't separate it. But, hold on. Actually, no, never mind. I'm sorry. I'm thinking of a different question. You can't separate this one. I'm thinking of a different one. We do need to look at the one you can't separate, though, because that threw kids for a loop that year. It was a few years back, so I need to find that one. we've got this differential equation. F of x is the particular solution here. So equation of the tangent line and use it to approximate f of 0.5. So we know our point would be 0, 2. We just get that from f of 0 equals 2. Our slope, Paul, how do we find the slope? Good. So, and we're going to label this to make it clear where we got it from, because depending on how they do points, it could matter. So, dy dx is 0, 2. That's going to be 10 minus 2 times 2, which will give us 6. So, there's our slope. So, our tangent line is going to be y equals 6 times x minus 0, if you want to put it there, plus 2. And so to approximate, we got f of 0.5 is approximately 6 times 0.5 plus 2. You can leave it like that if you want, but half of 6 is 3 plus 2 will give us 5. So f of 0.5 is 5, or approximately 5. Okay. A lot of times, differential equation problems will have one of these. I mean, I think we're pretty good at tangent line problems. So that, like, I would call that an easier section. I think most of you guys would agree. So, you know, make sure you get that low-hanging fruit that is easy to reach up to get those easy points. So, find the value of the second derivative at the point 0, 2. Is the graph concave up or concave down at that point? Give a reason for your answer. Okay, so second derivative, if we've got dy dx equals 10 minus 2y, we want to take the derivative, why'd that y do that? Take the derivative of that expression, which will give us our second derivative, right? So you don't have to separate, you're not integrating, so don't do the wrong thing on this. You're just taking the derivative. So dy, or d squared y over dx squared, second derivative, is going to be, derivative of 10 is 0, derivative of negative 2y, negative 2, dy dx, because that is a y, you got to put dy dx with it. Okay? So if we want to find the second derivative at 0, 2, we're going to get negative 2 times the derivative at 0, 2, which we already found in part A, right? We found that derivative at, the first derivative at 0, 2 was 6. And so that will give us negative 12. And so we would say since d squared y over dx squared is negative at 0, 2, the graph of y equals f of x is concave down at that point. Yes, that'll be fine. You may want to say, yeah, you can say less than 0 at. Make sure you have at 0, 2 somewhere. So you could do that by putting the line right here and putting it like this, or by saying at 0, 2, but make sure you state that. You don't want to just generally say the derivative is negative, because it's not necessarily negative at all points. Okay? Probably you got 2 points on part A. You probably got 2 points on part B. You probably got a point for the tangent line, a point for your approximation on A. You've got a point for your second derivative at 0, 2 here, and a point for your reason for concavity there. All right, so last part is going to be to solve the differential equation. So we got dy dx equals 10 minus 2y, right? Yeah, 10 minus 2y. All right, what do I have to do to separate? Multiply by dx. Get rid of that there. Then what will I have to do? We'll divide by that whole expression, 10 minus 2y. So that's going to give me 1 over 10 minus 2y dy equals, over here, I just have the dx. And I will need to integrate both sides. On this problem, the right-hand side is a very basic integral. You're just going to get x plus c there. The left-hand side is going to require a u du. It's not a huge u du, but I would probably actually write this one out. U is 10 minus 2y. So du would be negative 2 dy, which means that we need to put a negative 2 here with our dy and a negative 1/2 out front. And we would then have negative 1/2 integral of 1 over u du equals the integral of dx. And so that is going to give us negative 1/2 natural log of the absolute value of u, but I can do absolute value of 10 minus 2y, if I want to go ahead and plug that back in, equals x plus c. Okay, here. All right, it's got to be solved for y. You also have to do initial condition. You could do either one of those first, but I don't like natural logs, so I'm going to solve this for y first. So you could pull this in as an exponent, but there's an easier way. What's the better way to get rid of that negative 1/2? Multiply both sides by a negative 2. So you will get natural log of the absolute value of 10 minus 2y equals negative 2x plus c. Then we can do e to the power on both sides, which will give us 10 minus 2y equals, I'm going to go ahead and pull that c out as my coefficient, e to the negative 2x. And then just to solve for y here, we would subtract 10, divide by negative 2. So I've got y would equal, I can actually do this if I want, and I think I do want, ce to the negative 2x plus 5. Why did I not divide that first term by negative 2? Because of the c divided by negative 2 is still just going to be another unknown number. So you can do that if you want. You don't have to, but it makes it easier to deal with the next step if you do that. We okay here? Now we can plug in 0, 2. So we got 2 equals c e to the negative 2 times 0 plus 5. That is going to be 2 equals, e to the 0 is just 1, so I got c plus 5. I'm going to subtract that 5, and I will get negative 3 for my c. So my answer is going to be y equals negative 3 e to the negative 2x plus 5. Did you do it differently? Same answer. Did you find the C earlier? Yeah. Which is perfectly fine. And a lot of times it doesn't make a lot of difference in the difficulty there. Okay, so then they ask us to find the limit as x approaches infinity of this expression that we have. The key to this is those negative exponents are going to mess you up. So do negative 3 over e to the positive 2x plus 5. We're taking this limit here. What are we going to get for the limit as x approaches infinity of negative 3 over e to the 2x? 0, because you got a variable in the denominator. That bottom's going to get bigger and bigger and bigger. That's going to be 0. What about the plus 5? It's just going to be 5, right? So I will get 0 and a positive 5, which will just give me 5 for that. Okay. This is sort of what you can expect. There are some that are a little more. This one was not terribly difficult on the solving part. There are some that are sometimes more difficult, but this is the type of stuff they usually do with differential equations. So your homework has a differential equation and 3 multiple choice that you're going to do for me. So that'll be your assignment for tonight, and then we'll go over those tomorrow. If you are work keys testing tomorrow, we are, let me go ahead and give you, oh no. Surely. I've already one copy of it. I'm going to go around the copier and copy these real quick so I can get it to you guys. I'll be right back. There is not homework assignment that goes with this, but we'll have the FRP quiz on Monday, so make sure that you've got that done. You guys, tomorrow I'm really sorry to do our room and stuff. So if you can, try to watch the video over the weekend if you're. I wouldn't say it's that necessarily difficult. It's just kind of cool. So.
Can I take Raven's notes?
Yes.
She said I'll put it up for her.
Okay. Okay. Yes, that'll be great. That'll be great. That way she'll have it and